In this video, I'll be going over the derivatives of power functions. So introducing the power law, power functions are of the form f of x equals ax to the power of n, where a belongs to the set of real numbers and n belongs to the set of rational numbers. Real numbers include all rational and irrational numbers, and rational numbers are any number that can be represented as a fraction. And one thing to remember is that the derivative is the measure of the rate of change, or slope at each point. So first we'll look at the case when a equals 1 and slowly increase the n values. So for a equals 1 and n equals 1, you'll be graphing f of x equals x, and when we look at the slope of this line at any point, it is always the same, meaning the slope is 1, and therefore we can write the derivative function as f prime of x equals 1. So when a equals 1 and n equals 2, we'll be plotting f of x equals x squared. This one is a bit harder because the slope at every point is not constant. So we'll have to draw tangent lines at different points to determine the derivative function. So in this graph on the right, I drew the tangent line to the point -2, 4, and when calculating the slope of this tangent line, which is basically the slope at that point, the value that I got was -4. So we can plot this point, which is -2, -4, on a different graph, and with a few other points try to determine the derivative function. So in this graph on the right, I drew a tangent line to the point 0, 0, and this line has a slope of 0. So we can plot the point 0, 0 on the other graph we had to determine the derivative function. And since 3 points are necessary to draw a line or curve of best fit, another tangent line must be drawn, and I drew the tangent line at the point 2, 4, and this line has a slope of 4. So we can plot the point 2, 4 on the other graph. So after plotting the 3 points, we can draw a line of best fit, and the equation of this line is y equals 2x, which is actually the derivative of y equals x squared. And we can verify these results using the first principles that we learned earlier. So when you try to differentiate f of x equals x squared from first principles, we have the formula where the limit as h approaches 0 of f of x plus h minus f of x over h, and when you sub in the function, we'll end up with f prime of x equals 2x. So using the first principles and the derivative, we can see a pattern for the power law, and if we repeated this step-by-step process for higher degree functions, the rule for the derivative of a power function can be seen below. So for any power function, f of x equals ax to the power of n, where n is not equal to 0, its derivative is f prime of x equals a times n times x to the power of n minus 1. And thanks for watching.